Hello everyone. In this video lesson, you'll be introduced on how to use two formulas to help you factor perfect cubes. And the first one is the sum of cubes. So if you have a cube plus b cube, you can factor this out as a plus b times a squared minus a times b plus b squared. And for the difference of cubes, if you have a cubed minus b cubed, that is equal to a minus b times a squared plus a times b plus b squared. Okay, so this is the formula you're going to be using for this video lesson, and this will help you get ready for what's going to come next in this course of Algebra 2. So if you look at the first example, in the first example, we have x cubed minus 27. So 27 is a perfect cube. So what we need to do is, I'm going to do this for the first problem, but then I think you'll be able to follow for the next without using all of this, okay? So since you're seeing this for the first time, I'm going to show you how to determine what a is equal to and what b is equal to, and also a times b, so we can just plug them into this formula. So what I noticed first is that this is minus 27, and like I said, we know 27 is a perfect cube. So then what I need to do is I need to find a and b. So to find a, I'm going to take the cube root of x cubed, and when we take the cube of the cube root of x cubed, that's equal to x. So that gives you the value of a. So far we have a is following this formula. So a is x, and then the formula says minus. So now I need to find what a is equal to. So what I'm going to do is, I'm going to take the square of a, but a is x. So just take the square of x, right? Now to find b, this is b cubed. So I'm going to take the cube root of 27, and we have done this in class. The cube root of 27 is the same as 3. So then this is minus 3. Then next we need to find b squared. B squared is 3 squared, which is equal to 9. Okay, and then a times b, being that b is 3 and a is x, then a times b is 3 times x. So then I'm going to plug this into this formula. So what I need for a squared, this will be x squared. And then the formula says add a times b. A times b is 3x. And then add b squared. B squared is 9. So this perfect difference of cubes factors as x minus 3 times x squared plus 3x plus 9. And that is all for this example. Okay, so let's move on to the next example. Notice that there is a GCF here. So I'm going to factor out the GCF first, which is 3. So 3 comes out. So then this becomes x cubed plus 1. Now for this problem, we can't do anything else. Well, yes, we can. We can. Because 1 is a perfect cube. Okay, so if I take the cube root of x, that gives me x. So then notice that this is a sum of cubes, so I'm going to use the first formula. Okay, so this is equal to, keep the 3 outside as a GCF, and then this is x. The formula says you're going to add b, but b is the cube root of 1, which is 1. So times x squared, which is a squared, right? So that's x squared, minus a times b, but a is x and b is, in this case, is 1, right? Because x is x and b is 1 in this case, right? Because we take the cube root of 1, which is 1, so then this is just plus x. And what is b squared in this case? Well, if you take the square of 1, that's still 1, right? So then this is number 2, applying the sum of cubes, or perfect cubes, to that problem. So that is all for example number 2. Example number 3, this is review. This is a perfect square, and we have x squared, so we can follow that formula that says that if I have a squared minus b squared is equal to, this is a minus b times a plus b, and this was on the assignment from yesterday. So then this can be factored as x minus 7 times x plus 7. And I hope these are getting easier for you, and this will come in handy again on the next few lessons that I'm going to be going over in class. This one here is we can't apply the sum or the difference of cubes. This is called the sum of squares. Okay, so let me just go back and remind you that this one here is a difference, if I forget, of squares This one is not a difference. This is a sum of squares. Okay, and for this one, we can't do anything, at least not yet, but we'll get to a point in which you'll be able to solve higher order polynomial equations such as the cubes or 4 degree or 5/5 degree, so on and so forth. So this is a sum of squares, and we can't do anything to this one yet, but I'll go over a lesson on how to determine the solutions once this becomes an equation. Okay, so for the next part, this is asking us to identify the linear factor, so that means we need to factor this out. So what I'm going to do is I'm going to use factor by grouping. So this is the first group, and this is the second group. So in this group, I need to find a GCF, and as you can see, this is x cubed, this is x to the second, so there's a GCF of x squared. And this one here is a 5 as a GCF, so I'm going to factor that out. So then I have x squared coming out as a GCF from the first group, then I'm dividing x cubed by x squared, that becomes x, and 3x squared divided by x squared is just 3. And the next one, I'm factoring out a positive 5. So then this becomes x, 5x divided by 5 is x, and 15 divided by 5 is 3. So this is the point of factoring by grouping. As you can see, we have the same binomial for both of the groups. So then I'm going to factor out x plus 3 and then put together this x squared and this plus 5. So then the question is asking identify the linear factor. Well, we know this one here is not linear, this is quadratic, right? So, but the problem is asking identify the linear factor. Well, this is the linear factor. So I'm going to come back and box this one in because that's what I'm being asked to find. Next example, same idea. I'm going to group these two terms together using factor by grouping. GCF of this term is there's a 2 and there's an x squared, so we can factor out 2x squared as a GCF, and from here I just see a negative lead, so I'm going to factor out a negative 1. So then first group is 2x squared as a GCF, then I'm dividing 2x cubed by 2x squared, that becomes x, negative 20x squared divided by 2x squared, that's minus 10. Okay, so that's the first group. Second group, if I factor out a negative lead of 1, and then this x becomes positive, and that 10 changes to minus. And again, as you can see, these two binomials look the same. So I'm going to factor them out as one, just one of them, and then put together 2x squared minus 1 in another parenthesis. And now this is what I'm being asked to find. This is the linear factor. Okay? And that is all for this lesson. See you soon. Bye-bye.